Today, let us look at combination of solids. In the figure shown, we have a cylinder and a cone. Now the figure is rotated and another cone is added. So we have one cylinder and two cones. In this figure, we have a cuboid, 3 cubes and 3 spheres. Let us look at a problem. A medicine capsule is in the shape of a cylinder with hemispheres attached on both ends. The length of this capsule is 15 mm and diameter is 4.2 mm. Find the volume of medicine that can be filled inside. Let us draw the diagram first. We have a cylinder. Let us attach two hemispheres on both ends of the cylinder. Now we are given the length of the capsule as 15 mm and the diameter is 4.2 mm. We can see that the diameter of the cylinder and the diameter of the hemisphere would be the same, 4.2 mm. The radius would be 2.1 mm, half of the diameter given. Now we can see that the radius of both the hemispheres would be 2.1 mm each. Hence, the height of the cylinder would be 15 minus radius of both the hemispheres, or 10.8 mm. Now we have to find the volume of medicine that can be filled inside. Since the given solid is a combination of a cylinder and two hemispheres, the volume of medicine that can be filled inside would be equal to volume of the cylinder plus volume of the two hemispheres. So we could write volume of cylinder plus volume of sphere. Now volume of cylinder is pi r square h and volume of a sphere is 4 upon 3 times pi r cube. Let us take pi r square common. So we have h plus 4r by 3 in the bracket. Let us substitute the values and simplify. Upon calculation, we see that volume of medicine is 188.5 cubic millimeters. Let us look at another problem. A pencil stand is made from wood. It is cuboidal in shape and has 12 conical depressions to hold crayon pencils. The cuboid's dimensions are 45 by 10 by 3.5 centimeters. The radius of each depression is 0.4 centimeters and depth 1.4 centimeter. The stand needs to be painted black. Find out the surface area to be painted. Let us draw the diagram. We are given a cuboid and its dimensions. Now, we are going to make conical depressions in this cuboid. We must note that while painting the cuboid, we would not be painting the circles anymore. However, there is a conical depression in place of the circle. So, we would be additionally painting the curved surface area of this cone. We are also given the radius of this cone as 0.4 cm and its height as 1.4 cm. So, the surface to be painted would be equal to surface area of cuboid minus area of circles plus the curved surface area of the conical depressions. Let us substitute the formulae. So we have 2 times LB plus BH plus LH as the surface area of the cuboid. Since there are 12 circles, so we would subtract 12 times pi r square. The curved surface area of a conical depression would be pi r L dash. Hence the surface area of 12 depressions would be 12 times pi r L dash. Wait, but we are not given L dash. Let us find out L dash first. We shall use the Pythagoras theorem. Recall that a cone is made by rotating a right triangle along one of its shorter sides. So L dash would be equal to square root of 1.4 square plus 0.4 square. Let us calculate. We need to find out the square root of 2.12. You could either use a scientific calculator or you could use long division method. Let us go through this quickly. We form pairs of the numbers. So on the left of the decimal, since 2 is alone, whereas on the right of the decimal, 1, 2 can be clubbed together. Now let us see which square can be subtracted from 2. The smallest square is 1. So 1 times 1 gives me 1. I subtract that and I get 1 as the remainder. The next pair of numbers, which is 1, 2. So I have 112. Now double the quotient, you get 2. Now we need to put a number next to 2. So 24 times 4 gives us 96. So the remainder is 16. Now since there isn't a pair of numbers next to 12, let us take 0, 0. So the new number is 1600. Now double the quotient once again, but without the decimal. So 14 2s are 28. Now we need to put a number next to 28. What shall come in the ones place? Let us try 5. So 285 times 5 gives me 1425, a number less than 1600, which gives me a remainder 175. Now let us copy another pair of zeros. Let us double the quotient again. So 145 times 2 gives me 290. Now what shall I put in place of the question mark? Let us try 6. Yes, that gives me a number less than 17,500. So my square root comes out as 1.456. Let us round that off to the second place of decimal. So I get L dash as 1.46. Alright, let us try to simplify the formula now. We can take 12 pi r common from the second and third terms, which leaves us with minus r plus L dash in the bracket. We can rearrange these terms and substitute the values and calculate. So the surface area to be painted is 1300.9 square centimeter. Let us look at another problem. A right triangle whose sides are 3 cm and 4 cm other than hypotenuse is made to revolve around its hypotenuse. Find the volume and surface area of the double cone so formed. Alright, something interesting is going to happen. We have a right triangle, but we are not rotating it along one of its shorter sides. The shorter sides are given as 4 cm and 3 cm. I can easily figure out my hypotenuse using the Pythagoras theorem. Now I am going to revolve this triangle along its hypotenuse. Can you imagine what is going to happen? I am getting a strange quadrilateral. However, if I connect B and B dash, can you see that AB, B dash would be forming one cone and C, B, B dash would be forming another cone? The question also mentions a double cone so formed. Let us look at these triangles. We can see the right angles. Let us call angle ABM as theta. So angle MBC would be 90 minus theta. Now I can figure out the other two angles in these right triangles. Something interesting is happening. Can you see that angle ABM is equal to angle BCM, which is represented by theta? Similarly, angle BAM is equal to angle CBM, which is 90 minus theta. Also, angle AMB is equal to angle BMC, which are right angles. So we can see the triangle ABM is similar to triangle BCM. We are using the angle property. Now we know that in similar triangles, the ratios of the corresponding sides is also equal. So AB by BC is equal to BM by CM is equal to AM by BM. Now let us call the height of the bigger cone as H1 and the height of the smaller cone as H2. The radius for both these cones is going to stay the same. Let us substitute the values for these sides. We get 4 by 3 equals r by h2 equals h1 by r. Let us take this in pairs. So we have 4 by 3 is equal to r by h2 and 4 by 3 equals h1 by r. Or we could also write h1 and h2 in terms of r. Do you recall that h1 and h2 together form the hypotenuse of the triangle ABC that we started with? So h1 plus h2 equals 5. Let us substitute the values for h1 and h2 in terms of r and solve for r. We get r equal to 2.4 centimeter. Likewise, we can find the values of h1 and h2 now. h2 comes out as 1.8 centimeters and h1 comes out as 3.2 centimeters. Let us label our diagram now. Alright, let us look at our cones so formed. Now I know the radius and heights for both these cones. I also happen to know the slant heights of both these cones. Now I have to find the volume and surface area of the double cone so formed. This is simple. I just have to add the volume and surface area of the individual cones. So volume is going to be volume of cone 1 plus volume of cone 2, which is 1 upon 3 times pi r square times h1 plus 1 upon 3 times pi r square times h2. Similarly, for surface area, I am only going to look at the curved surface area. So it shall be pi r L1 plus pi r L2. Let us simplify the formulae and substitute the values. Combinations of solids require a little visualization. So the easiest way to solve a question is to divide it into simpler solids that you identify and be sure of which surface areas are to be counted.